Hi everyone. So last week I think we had the weekly contest 381, right? And there were four problems, four very interesting problems. Specifically the last one being a very good problem which I think only about 150 people solved, right? So in this particular lecture, let's try to cover up the first and third problem which were kind of like the same. In probably a next lecture or a next video, I'll go ahead and give the question 2 and question 4's explanation as well. So before starting, give the video a like, to subscribe to the channel if you are new here, and let's get started. So if I go and look at the problem, let's first look at the actual problem statement, try to dice it down, and then let's go ahead from brute force and keep on optimizing, right? So first part of the problem, the first version, which is the first problem, said that let's say you are given a string word, right? So there is a word given to us which contains only English characters, so A to Z. Now if you remember, there used to be a telephone like this where each number from 2 to 9 had some letters associated with it. So 2 had ABC, 3 had DEF, right? And so on and so forth. So if you, let's say, had to type, let's say, my name, Bharat, Bharat. So what I had to do, I had to press this 2 key twice to get B on the mobile screen. Then again, press this fourth twice to get H, and so on and so forth. First, press once this 2 to get A, then press this 7 thrice to get R, then again once this to get A, and then once 8 to get my T. So that is how you used to type before the era of smartphones, right? Probably like Gen Z people would not relate to it, but yeah. So given this kind of a phone, we are allowed to remap all of the letters, right? So for example, what I can do is I can say that, okay, now 2 will have AFG. So first letter here means that, okay, I'll have to type 2 once to get A, and then do 2 like type it twice to get F, type it thrice to get G. Similarly, you can see that all the letters have been remapped. So basically, given a string, I have to remap the letters on the numbers in this keypad so that when I want to type that particular string, I use as minimum presses as possible, right? So for example, if I take my name only, so let me go ahead and do that. Go to whiteboard essentially. So let's go here. Yeah. So let's say I have to type this name, Bharat. So now if you see what I had to do to type this B, I had to do 2. To type this H, where was H? GHI, so 3. And similarly to type this A, I had to do PQR, which was like kind of 3 times 7 to get to the R state, right? So what I can do is I can remap the characters in such a way that, okay, now I need just 7 to probably get R. So what I can do is at 7, instead of PQRS, I can remap it probably to RPQS, because PQS I don't require, like they are not there in my string at all. So I don't care about where they occur. I can reduce 2 presses now by just remapping R to the beginning of this 7. Similarly, what I can do even in this H, like 3 or 4, A, B, C, D, E, F. Yeah, so actually it would be 4 if I think about it, GHI. So I can remap it again to probably HIG if I want. Or what I can do is, in fact, the 3 which had DEF are also used there. So I can just move my H here and do it HDEF, right? So what you have to do is you have to remap all the characters to a new variation in the number pad so that your desired string, you require the minimum number of presses for it. Okay. So just pause the video for a moment here and think what could be the optimal way, right? Okay, so great if you were able to think. The very simple idea that comes to the mind is, best case scenario, we would want to get all letters typed with one click, like we do in real world smartphones, right? So ideally we would want that, but think about it, is that even possible? So the answer for that is no. Why? Because if you think about it, we just have a few numbers, 2 3 4 up to 9, so 8 digits. So we can at max make 8 characters to be one click. Then if you think about it, we can make 8 more characters to be 2 clicks, which just come after the first character. Then 8 more characters at third click, and so on and so forth. So if you try to simplify this idea, right? If you try to simplify this idea, you would think something in these terms that, okay, the ones that I would want to put at one click should be the most frequent ones. So greedy, kind of like a greedy, clear greedy. Why? Because you have to minimize the number of clicks, number of presses. So if there is one character, let's say A, which occurs 5 times, and there is, let's say, another character, let's say E, which occurs just twice, and you have a choice. Do you want to make A as one click, or would it be better to make E as one click? So the answer would be obviously this. You would want to make A as one click because you will be saving some 3 clicks now, right? So if we calculate, if for A I take 1 click and for E I take 2 clicks, so the answer would be what? 4 plus 5, 9. Whereas if I take 2 for A, 5 into 2, 10, it is already more than this 9. Which is obviously the case. Like, the more the number of frequency of a particular character, the more likely you would like to keep it as one click. Okay. So if that idea is clear, now our question in a way reduces to, let's find frequency of each character. Once we have the frequency, we would try to arrange them in windows of 8. First window of 8, you would try to put all of them in one click, right? Windows of 8, but sorted by the frequency. So more frequent ones will come at one click, the most frequent 8. Then the next most frequent 8 would come at the second click, so on and so forth. So we just need to do these 2 steps to ideally go ahead and model our solution. Okay. So first questions, how do you go about calculating frequency of each character, right? So since we have A to Z, which is kind of like a small number, what we can do, for each character you can simply loop, have the frequency and store it in a vector. So we can create a simple vector. We can run a loop from A to Z, count, and then just push this count into this vector, right? Then I can sort this array of 26 characters in the reverse order and then make buckets of 8. So let's just go ahead and actually live code this quickly so that we are able to get through our solution. So what I can do is, let me create a vector of int, which is the frequency count. So what I'll do, I'll say for character A equal to A less than equal to Z, A plus plus. So I'm coding this live because it's a relatively easy problem. If it would have been tougher, I probably would have got a pre-made solution, which I already have from the contest, but let's just write a new one. So for this particular character, I would need to check each of the element in this word and check if it's equal to this character. If yes, then I just do count plus plus. So I'll say current count equal to 0. So I'll say for auto it word, if it is equal to A, then do count plus plus, right? And let me just do cout count for now, just to check if we are actually able to run this loop well. And then what I'll do, I'll just push this frequency count into my array. Next step, sort this array. So sort frequency count dot begin, frequency count dot end, reverse this array, because we want the sorting to happen in reverse order. This would sort it in ascending order, so we want to actually reverse it. This is a very, like, you can say, simpler way than writing a comparator. Like, I always prefer, if I just want to do it in decreasing order, I always prefer doing this. It spends some less time in, like, than comparing probably a comparator. Okay, so sort reverse. Now we have it in descending order. Now we want to make windows of 8. So if I think about windows of 8, 0 to 7, the first 7 characters will be assigned 1. They would be assigned to 1 click. Then next, 1 to 8 characters, sorry, 8 to 15, like the indice is 8 to 15, 8 character to 15 character, all of them will actually get how much? All of them will get 2. They would be assigned to 2 presses, right? And so on and so forth. So what I can simply think about this as that if I have some index idx and if I divide it by 8, so 0 is 7 divided by 8 gives me 0. 8 to 15 divided by 8 gives me 1. Next, 16 to 23 divided by 8 gives me 2. So on and so forth. So essentially, if I think about it, index by 8 gives me 1 less, right? This gives me 0, this gives me 1, this gives me 2. So plus 1. And this would actually give me the number of clicks required to get to that particular value. Okay, so now what I need to do, I know the frequency, that okay, some character occurred 10 times. I know how many presses I need to get that character on the screen, so by this formula. So if there are 10 characters and I need 2 clicks or 2 presses to get them on the screen, the total number of presses will become 10 plus 2. So what I can do, I can initialize an answer as 0, and what I can do, I can run a loop, I equal to 0, I less than frequency count dot size I plus plus. So I have my index. Now if you think about it, number of presses required is equal to I by 8 plus 1. So I by 8 plus 1 gives me the number of presses. Now in the answer, I would need to add frequency of I into my number of presses. So how many times the number occurs and how many presses it is required to put one of this character on the screen. So I can simply return the answer. Okay, so if I run this, there is a compile time error. Okay, so there needs to be a comma here, and I think I did dot. Okay, frequency. Okay, I think it's frequency count. So okay, okay, so we are, I think, able to get good frequency like ABCD 11 and rest 0, and I'm able to get my answer 5. So what I'll go ahead and do, just remove this. Okay, run this again once more just to check the answer. Let's probably take all the test cases. Yeah, so 5 and 12, which matches, and I'll probably click submit. Okay, accepted. I think I can simply copy paste this to the next one as well, and I think it should get accepted as well. Let me just run it once quickly just to see if we are on track, and we are on track, and let's click submit. Yep. So the only major difference between these two approaches, these two questions, was that in this particular one it said that all the letters are distinct. So in a way, all the letters have 1 count, so you did not even need to worry about which character should be placed where. Like if I just go ahead and start assigning it one by one, like first character goes to 2, next character goes to 3, next to 4, next to 5, next to 6, so on and so forth, and circle back. So even in that, everything would have worked fine. So that would have been a simple brute force, right? But if you think about it, this frequency logic is also not super difficult to come up with. Like, I literally thought this was a one of the easiest third problem that I've seen in a while in Leetcode Contest, right? So yeah, that is about it. So if you think about the time complexity of doing this, what we have done 26, like we are iterating on 26 characters, and for each of them we are going over the entire strings 26 into n. Then we are sorting, which is just the array of size 26, so 26 log 26, which is kind of like O1, nothing huge. Similarly, this counting is also just O of 26. So main complexity is this part, which is 26 into n. If someone asks you to reduce this further, you can actually do it. You don't need to loop over all the characters. You can have a map or something in place, or an array probably of size 26 having all zeros. I can in fact do that. So let's have an array of size 26 having all 0. And what I can do is I can just iterate on my characters of my word. And what I can do, so whatever this it minus a is, I'll do that's frequency count plus plus. So what will happen if it is, let's say b, so b minus a will be 1, so I'll go to 1 and do plus plus. So now I'm just sorting it like I'm doing it here and just answering. So this would now be n and not 26 into n. So let me try this as well quickly. Okay, so I think this also submits with accepted. Great. So that was the idea of the question. We have optimized it even further from 26 into n to just an n, right? So that is all there. Okay, cool. Then let's see you guys tomorrow, where I'll probably take up the second and fourth problem. Fourth was very complicated, so I'll try to make different solutions, brute force, etc. Right? So if you like this video, go ahead and please like this particular video and do subscribe to the channel, right? And even try to share it with your friends so that more people can get to know that we do Leetcode contest discussions, right? Cool then. Bye bye.